Okay, so looks like the only thing that changes on number 8 is these numbers here over here, the -8 to 8. So now that I've got those set up, I'm ready to integrate this because the derivative of e to the x is e to the x. So e to the theta is still e to the theta, it's just a different variable. The derivative of negative cosine theta would be positive sine theta. So you okay with both of those? It's just a theta instead of an x. So if the theta is what's messing you up, you know, don't let it, because it doesn't make any difference really. Just the variable for this question. Okay, for me to say this is equal to this, I have to keep up with the 8 and the -8. So one time, plug in 8. The next time, plug in -8. So I've got e to the 8th minus the cosine of 8 minus e to the -8th plus cosine of -8. Now, if you heard me a few minutes ago giving Taylor a hint here, these two cancel out, and that's something you learned in pre-cal, but it's been such a while. I kind of understand why you didn't remember this. You remember how trig functions are even or odd? There's even trig functions and odd trig functions. Well, cosine is considered an even function, which means whether you plug in a positive theta or a negative theta, you get the same thing. So think about like in a unit circle example. The cosine of 30 is the same thing as the cosine of -30. The cosine of 45 is the same thing as the cosine of -45. So for that reason, since these are equal but opposite, because one's negative, one's positive, those will cancel out. And so I'm left with the e to the 8th minus e to the -8th. And we really don't like negative fractions, so I would probably write this as 1 over e to the +8th. And that's what I would get for an answer.
You don't do anything further?
Mm-mm. You can check with your calculator, of course. It's going to be some weird, messy decimal, but this should be that same weird, messy decimal.
It won't want you enter it into the. It won't want you enter it into WebAssign as a decimal. It says that it's wrong.